This is a typical trigonometry problem that brings fear into heart of a lot of trig students. But don't let it bother you. Just follow the rules that are laid out in doing a problem like this and work through it. Now in my class, I always tell students to start by putting everything on one side, setting it equal to 0, but that's already there. Factor out anything that's common between the terms, which there isn't anything. Make sure that I'm all in the same trig function, which is also the case. But now what I see is I have something squared minus 3 times something minus 2, which is reminiscent of something that's quadratic. So what I want to do is find the roots of this using the quadratic formula. So I'm going to let sine of x be the solution to the quadratic formula. Now, a is equal to 1, b is equal to minus 3, and c is equal to minus 2 in this case. And I'm just going to use a quadratic formula. You know, if it's factorable, factor it. But here I have sine of x, not x. You have to imagine that this is, sine x is your variable. So sine x equals negative b plus or minus the square root of b squared minus 4 times a times c. Now, every time I do the quadratic formula, I actually write it out that way. The whole thing over 2 times a. Reason being is I make fewer mistakes. Okay, I don't like making mistakes. And since I have to teach in front of lots of students, I find ways to avoid it. So negative of a negative 3 is 3. Plus or minus the square root of 3 squared is 9. Minus 4 times negative 2 is plus 8 over 2. Now this doesn't look pretty, but don't panic. Just keep plugging away. So this is 3 plus the square root of 17 over 2. Now I'll have to say, plus or minus, excuse me. I have to say that is not standard. That is not standard at all. I mean, what I mean by standard is not on the unit circle. So what I'm going to do is then come over here and I'm going to solve the equation sine x equals 3 plus the square root of 17 over 2. And then solve sine x equals 3 minus square root of 17 over 2. Now since these aren't standard and I'm not forced to go use the unit circle, I'm going to use my calculator and the arcsine function. So that means x is equal to sine inverse, or arcsine, 3 plus the square root of 17 over 2. And over here, x is equal to the sine inverse, or arcsine, of 3 minus square root of 17 over 2. Okay, now let's go to our little machines that we all love and enjoy. Turn it on. And I'm going to do the sine inverse of, let's see what it says here, 3 plus the square root of 17 divided by, whoops, I need a parenthesis, divided by 2. Now make sure your parentheses are okay. Now the numerator has to be all in parentheses in and of itself, so that closes off that, that closes off that, and that closes off that, so we should be okay. Now this is error in the domain. So then, in other words, what I'm putting in the domain, what I'm putting as the input into the sine inverse function doesn't work. And I'm thinking it's not working because that number right there is greater than 1. So this case right here, there is no solution. Now over here, let's see what the calculator gives us. So I'm just going to hit go to and make a tiny change here. I'm going to come here and I'm going to, that's very blurry, isn't it? I'm going to come here and I'm going to change the plus to a minus. Oops, minus. Let's see what I get. Okay, I get minus 0.59626. Minus 0.5963. I always tell my students to round to the 4 decimal place accuracy. All right, so there is one solution. Now, we have to think about this because trig is really tricky. I'm trying to solve for all the solutions between 0 and 2 pi, including 0 but not 2 pi. So I have to think about this for a second. Sine inverse is defined from minus pi over 2 to pi over 2. So my output here, this is going to be between those two values. And since it's negative, it's in this quadrant right here. So that's where x is. That rotation angled clockwise rotation. But I want it to be between 0 and 2 pi, which isn't negative values. So I just want to rotate it all the way around once to get one of my solutions. So adding 2 pi gives me one of them in the right interval. Now the other one, since sine of x, since this is giving me a negative value here, that means sine is going to be negative in quadrant 4 as well as quadrant 3. So I need to think about what is this angle right here when that's positive x. Now remember, negative x is this, and I want a positive x as a reference angle. Okay, so that means my other angle is going to be 0.5963 plus pi. So what makes these so fearful to students is this part right here. What I suggest always, use the idea of a reference angle, use the idea of the unit circle and intervals, and know what your calculator is giving you so that you can come up with the right answers. And again, there are no shortcuts to this, so just do a little thinking at the very end and you can do it.